Good afternoon. My name is Michael Asokwa,
My name is Dean Roberts.
And my name is Will Custer.
and today we'll be presenting our semester case project, which shows how we enabled HTTPS, configured SSL keys, and analyzed TLS traffic for our AWS hosted website. I will demonstrate how HTTPS and SSL were enabled.
I will present some of the TLS traffic analysis.
And I will continue that analysis and then wrap things up for us at the end.
So the first step in our project was to set up HTTPS on our website, which was done using the certbot tool on the Apache web server to request and install an SSL TLS certificate from the Let's Encrypt Certification Authority. So in beginning this process, we have to set up a domain name for a website. This is because certificate authorities such as Let's Encrypt cannot issue certificates to raw IP addresses. They need a domain name in order to enable SSL and the associated certificate. So I use this website called noip.com. There are other websites you can use, but this is one that I used. If you go to my account dashboard, you can see, well, whenever the notes, it's loaded now. So you'll be able to see that I have already created the DNS hostname. If I click on modify, able to see some of the details. You can see when it was created, which was 28th November. You're able to see the IP address. So this is the IP address of our web server. This is the host name that I gave it, Globecake Travel. This is the host extension that was given to me. You can see that this is a type A DNS record. So that's the appropriate type of record that maps a host name to an IP address. So I'll just hit save on that. Doesn't change anything. So now that we have this IP or this domain name, we'll be able to go to the certbot tool in our command line for a server and be able to set up HTTPS. So I'll launch my AWS console. We will go to EC2. This is the EC2 dashboard. We have one running instance just for our WordPress instance. So this is the server that has all of our website info. You can see the IP address. We will hit connect and we'll be able to connect to the command line, which is a Linux command line. Now, I've already done the steps to search to set up HTTPS, so I won't be able to go through that again. But for demonstration purposes, I'll show you some of the commands that I used. So this was to install the certbot plugin. Then this was the command that requests a certificate, and after which it redirects all traffic through the HTTPS protocol. So you can see it's the same certbot tool that we're using. Apache is the web server, and this is the command for certificate. This is the domain. So this is what specifies the domain. You can see our domain name here. So when I originally did this command, I was running into some issues. I was running into this error, unable to find a virtual host listening on port 80. So basically what I had to do, I had to set up a virtual host on the port 80. And sort of the idea behind it is that I have to prove that this domain actually belongs to my website. So what I did is that I used this command to insert the configuration file. So this is the configuration file that I came across and that I used to set up a virtual host. So you can see again, this same domain name is coming up a lot. And I think these were the commands that were used in order to set up a log. So once I set this up, I went back to this command and it was able to work. So that's just for demonstration. What I'll be able to do, I'll use this command called sudo certbot certificates. So if I do that, you can see our list of certificates. We have one, which is the name that was given to it is the same domain name. You can see the domains is our domain. You can see the expiry date, which is 26 February of 2026. We can see the file path where it is located in the server. If I went through the process again, I'll be able to show you sort of verification of these file paths, but you can definitely see that there is an active certificate that was created. So now that we've seen this on the command prompt, we'll go to the website. So that's for demonstration. Originally, when I created the website, this was the URL. So let's see, it's not secure. You can see it's a warning. Don't enter any sensitive information because it's not secure. It can be stolen by attackers. If I was uploading, if I loaded this website on another browser, it would even load because it's only because I've turned off security warnings that allow me to load this website. So after I created the domain name, this is the URL that was created. So after I went through the no IP address, it created this URL. But now that we set up HTTPS, all traffic through this URL will automatically redirect to this URL. We'll be able to access the website through there. So to demonstrate this, if I put HTTP local travel, you can see it will automatically redirect to the HTTPS. You can see HTTPS here. Click on settings. You see connection is secure. Certificate is valid. You can see the same validity dates, the same creation date that we saw in no IP, the same expiry dates that we saw in our console. So this is all sort of for verification purposes. So another thing is that when I first set up HTTPS, all of these pictures that I have on my website weren't originally shown. So in order to fix that, what I had to do is that I had to use a plugin on WordPress in order to replace the URLs of the old URLs of the images which were connected to the old domain to new URLs that are in accordance with the new domain name. So if we go to our login page, WordPress login page, we log in, we're at the admin page, go to plugins. You can see I installed this plugin called Better Search Replace. So this is sort of a SQL plugin really. It runs SQL commands in order to replace um, on our WordPress database. So if we go to tools, you're able to see the tool is here. You're able to search and replace. So we search for anything that has the old domain name inside, then we replace with a new address. Select tables. Just select all the tables. There was a command to select all of them, but honestly, I can't locate it at the moment. So select all the tables, run a dry run. So this makes no changes. It's a dry run. So you can see it says that there is 0 tables that were found that need to be replaced. 0 changes were made. Um, this of course will show because I already did the replacement. And then if we uncheck for dry run, it will do all the processing. But again, it will show 0. Originally, it was around 20 or 30 cells that needed to be replaced. So we have already done this. So now that we've done this, you can see, of course, that the pictures were showing on the website. So you can see all of our pictures about the World Cup, which will be coming very soon to the United States, are all available on the website. So now that we've established this, I'll go into how we set up the SSL. So in setting up SSL analysis, well, before that, I'll even go to this website. This is just sort of a website that can sort of test and prove that SSL capabilities are on our website. So it's called SSL Labs. You can see we put our domain name in the website URL. So that points to our domain name to do the testing on. So I'll clear the cache just to run this freshly. So you can see it going through the various motions, testing the various TLS protocols. You can see it's our domain name, it's our IP address. See, it already knows as trusted on all the platforms. So let's run through this. You can see the same dates that we've already seen. They're all showing up again. So this all goes to show the security measures that are present in HTTPS, the validity measures that you can use to make sure that your website is secure. So you can see our website has an A rating for security. And you can see that this server supports TLS 1.3. All of this information we'll be seeing time and time again. So next, I'll show how we configure the SSL keys. So any web browser such as Google Chrome automatically generates SSL keys. It's just a matter of logging them. So in order to log them, what I did is that I went to my control panel. We have to set up something that's called an environment variable. And this is sort of a legacy feature of Windows, so that's why we're using the control panel. We go to System Settings, Edit System Environment Variables. Click on Environment Variables. You can see I added a new user variable called SSL key log file. If we click on Edit, you can see variable name, variable value. So a variable value is a file path that this file is located in. So now just for verification purposes, I'll go to my command prompt and I'll use this command. You can use the echo command, echo SSL key log file, run the command. You can see the same file name or the same file path that we already established that I created. So this sort of verifies that the variable was created successfully. And of course, if I go to my file explorer, I go to users, my user, you can see the folder, you can see the file, you can see all of the SSL keys that have been generated since I created this file, which is a lot. It's a lot of files, a lot of keys. So you can see that the file size now is even 29 megabytes. And it will continue to grow and grow as it automatically generates the SSL keys. So now that we've established that we have HTTPS, we have our SSL keys, we'll be able to perform our TLS analysis. So I'll load up Wireshark. Just to make sure everything is fresh, I'll close some of these tabs. Make sure everything is fresh for analysis. I'll load up the URL. So I'll be ready to access the website. And we're analyzing our traffic on the Wi-Fi. I'll hit start and I'll hit enter. The website has finished loading. I'll hit stop. Now, if I filter the traffic to our IP address, something that you may notice is that we don't see any HTTP packets. This is because under the HTTPS protocol, all these packets are encrypted. So this is where the SSL keys come in. What we have to do is that we have to load these keys into the Wireshark system. Once we do that, we'll be able to see HTTPS packets as well as some other TLS information that would normally be hidden. So if I go to preferences, go down protocols, all the way down to TLS, you'll see this setting, secret log file name. So these have some secret logs that we use to unencrypt our traffic. So we'll go to the same file path, SSL keys, the same log that we've already seen, and we'll hit apply. Click OK, and you can see there's more packets that have shown up, and you can see the HTTP packets. So now I'll hand over to Dean and Will to go through the analysis of our TLS traffic. Mm.
All right, well, thank you for passing it off, Michael. To start this TLS analysis, we're going to start with those first three packets showing the TCP three-way handshake. To begin, every TLS session starts with a regular TCP handshake. Since we're on that first packet showing this, we see our client sending SYN to initiate the connection. This packet is the server responding with the SYN-ACK, ACK, and the next packet is the client's ACK completing the three-way handshake. This establishes the underlying TCP channel that TLS, runs on top of. So for step two, we're going to look at that client hello, packet number 1162. So in this packet, we see the TLS handshake begin with a client hello. If you expand the TLS layer, you'll notice several important details. The client proposes supported cipher suites, provides its random value, and includes the extension survey name, which shows the host name it's connecting to. This is the client saying, here are all the cryptographic methods I support, and go ahead and choose one. So next we're going to look into packet 1200, which is the server hello. In the server hello packet, the server responds with a server hello, of course. Here the server selects the final cipher suite, sends its own random value, and begins transitioning to encrypted handshake messages. This marks the moment that both sides agree on that cryptographic method that they will use. Next, we're going to look at packet 1201, focusing on encrypted extensions, certificates, and then it being finished. So now that we're clicked onto this packet, we see the server sending its encrypted handshake messages. If TLS 1.3, the certificate verify and finish messages are encrypted with handshake keys. Um, uh, Although encrypted, we can still see these messages in Wireshark from the TLS record headers. Next, we're going to look at packet 1205, the client finished and keys established. In this client finished packet, the client sends its finished message. Once the packet is exchanged, both the client and the server have derived the same symmetric session keys. This is the point where the secure TLS tunnel becomes fully established. And now I'm going to pass it off to Dean to continue talking about our TLS analysis.
All right, cool. Thanks, Will. So with the handshake complete, as application data begins, our first application data message under normal circumstances without SSL key logging, this traffic would remain unreadable. We would only see encrypted application data. So this next step is going to be packet 1207, but because we enabled SSL key logging using the SSL keylog file environment variable, Wireshark now has access to the session keys. This allows it to decrypt the TLS application data. The HTTP GET request for the root of our WordPress site, host header showing our domain, user agent, and other HTTP headers. This is all plain text that normally would be encrypted inside TLS. Okay, so next for the decrypted server response packet is going to be 1284. This packet shows the decrypted HTTP response. Here we can see the HTTP 1.1 200 OK status code, content type, text/HTML, followed by hundreds of lines of HTML for our WordPress homepage. This demonstrates that our SSL key configuration is working correctly. Wireshark can now decrypt all of the application layer traffic. Okay, so in the session tickets packet, that's going to be 1321, we see a new session ticket. TLS 1.3 uses session tickets for fast resumption of future sessions, reducing handshake time and improving performance. And now I'm going to pass it off to Will to finish it off.
Awesome. Thank you, Dean. And now to wrap things up, in summary, using SSL key logging allowed us to decrypt the entire TLS session, including the HTTP GET request and full HTML response from our WordPress site. This section demonstrates our ability to analyze TLS packets, interpret each step of the TLS handshake, and highlight the exact information that becomes visible thanks to key logging. We'll shout out to Michael and Dean. Y'all were super fun to work with in this project, and thank you to Dr. SK for a great semester. We really enjoyed learning from you. And thank you so much for listening to this project.